Hello students, welcome to ComSci 127 Laboratory. I am Angelo Guiam from the Institute of Computer Science, and in this video, we will talk about Entity Relationship Model or ER model. At the end of this video, you should be able to define the Entity Relationship Model or ER model, understand the ER model, and model real-world problem using ER model.
Data is everywhere, and every day we give and consume data through our devices. Let's say Facebook, for example. We register our information and we generate more data from posts and other user activities. With the millions of users, Facebook holds enormous amount of data. And this data needed to be stored in such a way that's easier to retrieve and analyze. So there's where database comes in. Database is an organized collection of data, and database is useful not only in social media sites but also in different fields like finance, transportation, healthcare, and the list goes on. In this course, you will learn how to look and analyze real-world problems and construct a database design that would suit the need of the problem. But before that, we first have to learn how to understand our problem and our data. Data model. This is a logical structure of a database, and this is used to introduce abstraction and fundamental entities to a database management system or DBMS. Later on, we will discuss more about DBMS. Ang goal ng pagmodel sa ating data is to catch the scope of our problem and to understand how our data can be organized. Our data model would also dictate how our data will be stored, accessed, and updated in our DBMS. There are different ways on how we can model our data, and here are the three main types of data models. We have hierarchical model, network model, and relational model. For illustration, ganito yung itsura ng hierarchical model. Basically, it presents a tree-like structure. We have a single root data, and it branches out to different several children node. And it could go in multi-levels depending on the complexity of our data. Ang constraint lang nito is each node could only have at most one parent node. Of course, except for the root node. And then we have a network model. Somehow this looks kind of similar with the hierarchical model, but it is organized as a graph. Kung mapapansin niyo, meron din ditong node na merong multiple parents. And lastly, this is the relational model. We have a two-dimensional table that represents our data and it shows association with other tables. In the succeeding lessons, we will talk more about this relational model. And due to the need to represent more real-world problems with different complexities, here are more types of data models. In this particular video, we will talk about the entity relationship model or the ER model. It represents a conceptual design of a database, and this is represented by an ER diagram. Again, ER model for the conceptual design and ER diagram for the visual representation. An ER diagram has three components: entity, attributes, and relationship. Entity, a specific object, tangible or conceptual in the real world. Entity set is a collection of similar entities. This is represented by single or double rectangles. Kapag single rectangle, this is also called a strong entity. A strong entity is independent and always have primary key or identifying attribute. Now, an entity might have different properties or characteristics. For example, in a university setup, example ng entity is a student. And a student might have weight, height, or different properties that describes the student. Now, the primary key is the identifying attribute. This attribute makes the student unique. So let's say student number. On the other hand, we have weak entity denoted by double rectangles. In contrast to strong entity, weak entity are dependent on a strong entity. Similarly, this also describes an object, tangible or conceptual, but the set of properties or attributes that a weak entity has is not sufficient enough to derive a key attribute. So meron siya mga properties but not strong enough to designate an identifying attribute. So it has to depend on a strong entity. Additionally, the existence of a weak entity depends on a strong entity. In this example, we have two entities. We have employee and dependent. As you may notice, employee is enclosed in a single rectangle, which means it has an independent existence, thus this is a strong entity. And we have here the dependent enclosed in double rectangles, meaning that the existence of dependent depends on the employee. Since may mga employee na merong dependent and may mga employee na walang dependent, yung existence ni dependent, which is a weak entity, depends on the particular employee. Punta naman tayo sa attributes. If entity is an object in the real world, attributes are relevant characteristics or properties of an entity. This is represented by an ellipse connected to an entity. In this example, we have the entity student, and we listed three attributes. A student has a student number, a student has a birthday, and a student has an address. We can list more attributes depending on the context of the problem, but in this particular problem, we just listed three. And then we have a special type of attribute that we call the key attribute. This is the unique characteristic or identifying characteristic of an entity. This is represented by an underlined text. And picking the key attribute, we have to make sure that there are no two students sharing the same attribute. So for this example, some students might share the same birthday, and some students might share the same address, but no two students share the same student number. So in picking the key attribute, it has to be always unique. All strong entities need to have primary key. In the case of our weak entities, we have what we call partial key or partial discriminator key. This is the identifying attribute of a weak entity. It might not be globally unique for all the instances of the weak entity, but it needs to be unique for every association of this weak entity to its counterpart strong entity. For this example, we have a strong entity student that owns a pet. So our pet is a weak entity. Now, a student may own several pets. For example, student A owns 5 dogs. For each of the dog, we have unique names. That's why we specify it as our partial key. A partial key is denoted by an underlined text, but yung underline niya is a broken line in contrast to a primary key, which is a solid line. So what do we mean by not globally unique? So we can have a student A and student B who owns different pets but could have the same name. But it has to be unique for the set of pet that a single student owns. We have atomic attribute and a composite attribute. Atomic attributes are simple attributes that cannot be divided further. Example, height, weight, or student number. And then we have composite attributes. These are made up of more than one atomic attribute. In this example, we have the entity student and it has a birthday. And this birthday, we can break it down into month, date, and a year. So this whole birthday attribute is a composite attribute, and this month, day, and year are atomic attribute, composing the birthday. And then we have derived attributes. These are the values that can be calculated or derived from other attributes. In our example, we have your age as our derived attribute, because we can calculate age from the birthday. However, to standardize in our convention in this course, we should not assume that the prospect derived attribute is derived, unless stated in our problem. If it is not specified that the value is derived, let's just represent it as a simple atomic attribute. And then we have a single valued attribute and a multi-valued attribute. Single valued can take a single value and a multi-valued can take more than one values. For example, a student has a student number and a student can only have one student number. And then a student can have multiple contact number. So we specify it as a multi-valued attribute by a double ellipse. And then we have complex attributes. These are nested composite attributes and multi-valued attributes. And for this example, we have student and a student has a contact detail. And a contact detail can be composed of a home address, a multi-valid contact number, and a multi-valid email. The last component that will complete our ERD are the relationships. It shows association between entities and represented by a diamond shape connected to the entities. Hindi required na lahat ng entities ay nakakonect sa isa't isa. Only those entities with relationship with each other are given association. For example, employee has an employer, and an employee has dependent. As you may recall from our previous example, dependent is a weak entity, so it is represented as a double rectangle. In relationship, we also have two types, strong relationship and weak relationship. Strong relationship is an association between two strong entities, example, the employee and the employer. And weak relationship is an association between a strong entity and a weak entity. For this example, an employee may or may not have a dependent. And since dependent is a weak entity, we use weak relationship. To summarize, ERD has three components. Entity, that represents object, tangible or conceptual in the real world. And attributes are the properties or characteristics of an entity. And relationship are the association between entities. Now let's talk about the cardinality constraint. This is the number of times an entity participated in a relationship. Ibig sabihin, ilang beses pwedeng ma-associate ang isang entity sa isa pang entity. Mayroon tayong tatlong types ng cardinality, one-to-one, one-to-many, and many-to-many. In a one-to-one cardinality, an instance of entity A can be associated with at most one instance of entity B and vice versa. Ibig sabihin, si entity A can be related to entity B at most once, and entity B can be related to entity A at most once. In this example, person has passport. Ibig sabihin, ang isang instance ng person can only own one passport. And on the other hand, ang isang passport ay pwede lang maging pagmamayari ng isang person. Hindi siya pwedeng sharing. So, one-to-one cardinality. In a one-to-many cardinality, an instance of entity A can be associated with zero or many instances of entity B, and an instance of entity B can be associated with at most one instance of entity A. Yung isang side, 1, and yung isang side, 0 or many. In this example, we have customer has orders. So, isang instance ng customer can create different orders or many orders. And on the other hand, yung kada instance ng orders na yon, nakapangalan lang sa isang customer. Last is the many-to-many cardinality. An instance of entity A can be associated with zero or many instances of entity B, and an instance of entity B can be associated with zero or many instances of entity A. So example, student enrolled in course. So a course can enroll many students, and a student can be enrolled in many courses. Next, we have participation constraint. This is the number of instances of an entity that can participate in a relationship. We have two types of participation constraints, the total participation and partial participation. In total participation, each entity in the entity set must compulsorily participate in at least one relationship instance in the relationship set. Meaning, required yung entity to have a participation in the relationship. It is also called mandatory participation, and it is represented by double lines. In our example, we have student enrolled in course. So, as we can observe, si student may total participation siya dito sa relationship na to. So, it means that a student, for it to be a student, it has to be enrolled in a course. Pero si course, on the other hand, since hindi siya total participation, it can stand alone, even walang student na naka-enroll sa kanya. It can still be a course. In partial participation, each entity in the entity set may or may not participate in the relationship instance in the relationship set. It is also called optional participation, and this is represented by single lines. So using the same example earlier, entity course has a partial participation in this relationship instance. So paano natin malalaman kung ang entity in a relationship is a partial or a total participation? Basically, it depends on the context of the problem or the business logic. In this example, a student has to be enrolled first in the course before we can consider them as students. Or maybe a customer needs to buy a product first before we can consider them as customers. But on the other hand, let's say product, a toothpaste, a shampoo, even without a buyer, they are still considered products. So maybe they have a partial participation. Now, attributes to relationships. Now, we all know that an entity can have attributes because an attribute is a property or characteristics that describes the entity. But in some cases, we can also put attributes to a relationship. If we can minimize or avoid putting attributes to relationship, that is better because when we go to relational model, it is easier to translate ERD to a relational model kung wala tayong attributes sa relationship. So, first thing to do is, let's try to fit it first sa ating entities. Kung ma-fit natin yung attribute na yun to be a part of the attribute set of an entity, then that is better. But in some cases, especially to many cardinality, meron talagang cases na magkakaroon tayo ng attribute sa ating relationship. For this particular example, we have researcher works on project. And this is a many cardinality because many researchers can work on different projects and a project can be worked on by different researchers. Now, if you wanted to take note of the start date or ito yung date kung kailan nag-start yung researcher to work on a specific project, it will be very confusing for us kung saan natin siya ilalagay na attribute. Pwede ba siya maging attribute ni researcher? Very confusing because if we put start date as an attribute of researcher, then it is very confusing kung sinong project or kung anong project yung tinutukoy ng start date na yon. And same to putting start date as an attribute of project because we have different researchers working on the same on this particular project. So, very confusing kung kayo nung start date yung nakaspecify doon sa attribute na yon. So, in this case, we put start date as an attribute of the relationship. So let's try to solve real problems. We have here a problem and we have to create an ERD based on this problem. But first we have to understand our problem. A course is composed of a course number, which is unique, a course title, number of units, and number of hours. A course should always be composed of students. A student has a student number that is unique, a name that is further separated in its first name, last name, and middle initial. We have birthday, age, and address that can have multiple entries. A student cannot be called a student if they are not enrolled in a course. A course can have multiple students. A student can enroll in different courses. So first, let's try to isolate our entities. Looking back, entities are objects in the real world, and usually these are nouns. So let's try to think which of this can be our entities. So maybe we can have course and a student. Let's try to draw our entities using our notation. So we have course and student enclosed in a rectangle. Now let's try to add the attributes or the properties or characteristics that describe our entities based on our problem. So it says that a course is composed of a course number which is unique. So since that is specified as unique, we can use that as our primary key. And then we have course title, number of units, and number of hours. And a student has a student number that is unique. So again, we can use that as our primary key. A name that is further separated in its first name, last name, and middle initial. Birthday. We also have age. And an address that can have multiple entries. So that is a multi-valued attribute. Based on our problem, our entities are associated in such a way that the student is enrolled in a course. With regards to cardinality constraint, it says that a course can have multiple students and a student can be enrolled in different courses. So that is many to many. For participation, it says that a course should always be composed of students. So sounds like a mandatory. So this is total participation. And a student cannot be called a student if they are not enrolled in a course. So again, mandatory. So total participation. So for this problem, you can try to solve it on your own. Pwede nyong i-pause muna yung video and analyze the problem and try to construct an ERD out of this problem. For this problem, we have two entities. We have employee and dependent. An employee has a unique employee number, that is our primary key, a name that is further separated into first name, last name, and middle name, that is a composite attribute, and department number and position, so those are atomic attributes. And then for our dependent has a name, age, and relation to the employee, so we have three attributes for our dependent. And since, based on the problem, dependent is a weak entity due to the statement that a dependent should always have one employee to depend on, and an employee can also not have dependents. So we can say that this is a weak entity. So we can specify the name as our partial key in this case. For the cardinality, this is a one-to-one cardinality because it says here that an employee can only have one dependent. So kung mag-specify man si employee ng dependent, isa lang yung pwede niyang i-specify. So since this is a weak entity, we used a double diamond for our relationship. And take note that every time na merong weak entity, it was always a total participation. Ito, for our last problem, you can again try to pause the video and try to solve it on your own. For our last example, let's read the problem. A customer has a customer name, customer ID, which is unique, so that will be our primary key, sex, birthday, and age. Age is a derived attribute. Many customer buys many items, so that sounds like a many-to-many relationship. Each item has a unique barcode, which is our primary key, item name, unit price, and number of stocks. When the customer buys an item, the purchase date, quantity, and total price computed as unit price times quantity are recorded. So those are the attributes of our relationship. And a customer cannot be considered a customer if he or she did not buy any item. So that is total participation. So in our example, we have here two entities. We have customer, buys, item. For the cardinality, this is a many-to-many relationship, and customer has a total participation in this relationship.